Okay, so let's go over some of the vocabulary that you guys used when reading this. Let's say we have this radical expression here. The vocabulary for this term represented by n is going to be what? What is that called?
Index.
The index. That's right. The index is right here. That tells you what root it is. That tells you what power you have to take it to get rid of the root, right? Okay, so this x inside the radical is called, you guys remember? The radicand. That's right. So when I'm saying it's the radicand, it's all the stuff inside the root. So let's look at number 1. Have the square root of x plus 1, and then plus 2 is outside the root, equals 4. And I'm going to solve for x. So the first thing you need to do when you have a radical in your equation is get the radical all by itself. You want to isolate the radical. So I'm going to subtract the 2. So I have x plus 1 equals 2. And once you get the radical all by itself, then you can square both sides or take it to the power, the opposite of whatever the root is. In this case, it's the square root, so I'm going to square both sides. Okay, so what happens when I square both sides is all that's left on the left side is the radicand, the x plus 1. And then on the right side, I'm going to get 4. So I want to subtract 1. X equals 3. Okay, so the important part is after you solve, you need to check your answer. So I'm going to take the solution and plug it back into the original equation and make sure that it works. So I'm going to plug the 3 in. 3 plus 1 plus 2 equals 4. So in the radical, 3 plus 1 is 4. Square root of 4 is 2. And does that work? Is that going to make a true statement? Yes. Okay, so you guys do number 3, and I'll do it up here. And let's make sure everybody gets the right answer. Okay, number 3. Okay, so I'm getting y equals 38. And then when I plug it back in, it makes a true statement. So it's a good answer, and I'm going to keep that for a solution. Okay, so let's look at number 2. Number 2 is different because it has 2 radicals instead of just 1. So when you have 2 radicals, you want to separate them. You want to put them on opposite sides of the equal sign and then square both sides. If you try to get them on the same side, it really makes a big mess when you try to square both sides. So number 2 already has them separated. On the left side, you have a monomial. On the right side, you have a binomial. So when you square the left side, the square root of x minus 15 is just going to be x minus 15. But when you square the right side, you have to FOIL. You'll have 3 minus radical x times 3 minus radical x. So we've got to multiply the first terms, multiply your middle terms. You'll have negative 3 radical x and negative 3 radical x, so 6 radical x, and then plus x. Okay, so you just have 1 radical now. So I want to isolate that. I want to do the same thing that I did for number 1 and number 2. So I'm going to subtract x from both sides, and when I do that, those x's reduce out. I don't have an x anymore. I don't have a variable. And subtract 9. So negative 24 equals negative 6 radical x. Divide both sides by the negative 6. And I have 4 equals the square root of x. Okay, and so now when I have the radical all by itself, now I can square both sides to get rid of that root. So x is going to be 16. And you still need to plug that back in, make sure it's going to work. So I'm going to plug this back into the original equation. The square root of 16 minus 15 equals 3 minus the square root of 16. 16 minus 15 is just 1, so I have the square root of 1 on the left side. Square root of 16 is 4, so I have 3 minus 4 on the right side. 1 equals negative 1. That's not true. So I can't use this answer. It's just going to be no solution. That's an extraneous solution. That's right. Okay, let's do number 4. You guys try number 4, and I'll do it up here. Okay, so I'm getting that x equals 16, but when you plug that back in, it doesn't work, so it's no solution. It doesn't give you a true statement.
I don't like this 16.
Yeah, I think I'm noticing a pattern here.
Like, so anytime I equal 16, it's wrong.
No.